But we don't need any intros because you all know who these guys are. So we'll come to Ryan first. Ryan's going to kick us off. Why do we need, very broad question, but it will set us up nicely for the next hour. Why do we need to profile our athletes?
Yeah, I think it's a pretty important question because we have this whole idea around collective individualization. So it's this idea that you've got a large group of athletes, depending on how big your team is. They're all of varying degrees of physical abilities and experiences, and they all need certain things that kind of move the needle forward with them. So if we have the idea that general programs yield general results, then we need a way to like bucket and mailbox athletes in certain categories to where we can yield programs that are going to move the needle forward for those guys. So in order to make best use of our training time, we need to have the ability to see what the, for lack of a better term, the low-hanging fruit is, or where their limiting factors are and their weak links are in regards to their sprint performance. And so if you think of the entire annual plan, at least in, collegiate athletics or collegiate football, as like these mini blocks of time where you have access to these athletes to make actionable changes, we want to make the best use of that entire training block by being able to profile them, find their weaknesses, and attack those weaknesses as best we can. And so the whole idea of the general training plan and vertical integration is still in play. We keep everything in the program at all times, kind of raise everything up and train everything, but we're really attacking those individual weak links and abilities.
Just to play devil's advocate slightly before we dive into the questions, as you get more experience and that coaching eye develops, is there a way that you can potentially, without going through that process, bucket athletes so you can have specialized programs, not the general programs that you mentioned, but have specialized programs that are specialized for 3 or 4 people based on a bucket, and then another 3 or 4 people based on a bucket, versus striving for that like individual program?
Yeah, I mean, the whole idea is to say if you have 100 athletes, 100 individual programs is logistically impossible. So it's the whole idea of like, what do your logistics present to you in your environment? That's really going to dictate how many programs that you have running simultaneously. So, I mean, just take college football environment, for example. You usually have a number of coaches. Each coach is potentially responsible for a position group. And some of those position groups may be doing different things inside the training session or different portions of the year. So instead of saying we're going to program for that certain position group, we're going to program based on weakness. So it's just shifting the mindset and the training mentality around to say that our program is going to be running in tandem. You may have the ability to run 2 programs. You may have the ability to run 4. But how deep you go and how deep you profile is going to be based on your logistics, how many coaches you have, things like that.
Cool. JB?
Yeah, Ryan, I wanted to add to Rob's question. You personally, how do you respond to people who say basically, don't bother doing this individualization, just go for a maximum power output program and you'll be fine?
I mean, I think it's been proven that if you measure what matters in your program, so if you actually start to measure the things that matter, you see that different athletes are going to respond to different types of training, and different types of stimulus are going to yield different adaptations in those athletes. So if you just apply a general program, like we said, it yields general results. Some athletes are going to respond, some aren't. But in order to make best use of your training time, like be very targeted and specific about what these athletes are receiving. And so, for us, like we want to be very specific about what we measure. We want to be very specific about the stimulus that we're applying to these athletes to make it as best as possible.
Excellent. Les, just coming to you. I know I'm going to ask you the same thing as Ryan, but what's your reason for profiling? Just exactly echoing what Ryan said, or is there anything in particular that resonated so you can dive a little bit deeper?
Yeah, I think a lot of like my coaching philosophy comes from my anxiety about getting to the end and like making sure that I get the result that I need to get. So what I found, like once I started reading JB's research and all that, it was an easy way for me to knock off some of the basic physical qualities I had to get athletes into. And then I could shape it up with technical adaptations and things like, really making it like an art form But for me, it was being able to actually take it and program and then know from a physical standpoint, this athlete is developing a quality they need to develop. And as you know, in sprinting, like the goal isn't to just run at max power all the time. The goal is to run fast. So applying a stimulus where and when and how long has a lot to do with where the athlete fits in their bucket. So for an example, an athlete that needs to accelerate from early and doesn't have that physical capability to orient themselves horizontally, they might end up spending more time in that power bucket where they're working max power for a period of time that's a little bit longer than an athlete that has that capability and needs to touch on some of the speed strength qualities or the high speed qualities. So for me, it was an easy way to have an objective opinion on something and then be able to tell the athlete like, hey, this is why and this is where we're going. Because I'm dealing with like 21 to 22-year-old guys that are about to be millionaires, and they have 8 weeks, and their goal is really to maximize their speed for 1 to 2 runs. And I have to be able to look at it and know going into that period, into that competition period, that I applied the right stimulus. And Ryan was super helpful with us this year, and JB's research was super helpful as well. But we were able to look at it and say across 34 guys, we're going to bucket these guys. And there was like a lot of similarities. Like we ended up having 4 different buckets, and it was relatively easy to run in a session because the only thing that we actually individualized was the load that they're running with and sometimes the volume. But we were able to look at it and really take a step back from overcoaching the technical side of it. And we're seeing adaptations happen on the technical side just by applying the right stimulus that the athlete needed. So a little bit of a long-winded answer, but
No,
yeah.
it's all good. All good. Dive in, Ryan.
Yeah, I mean, I think just kind of like expand on what he was talking about. If you essentially look at your entire training plan, it's essentially the slope that you take to get there is going to change based on your strengths and weaknesses. So it's like, why stick to these predetermined timelines of, max force, max power, max velocity when you're moving away from the stimulus when they're still improving inside of it? So it's like if an athlete needs to apply heavier loads of body weight, they need to work on acceleration. Like, why move away from those exercises too soon when there's still a lot of stimulus to be able to be applied to those athletes? So traditionally, it's like if you look at an 8-week cycle, you're still going to respect the training plan, the training pipeline of good training. It's like, we're going to start with our acceleration work. We're going to work short to long, and we're going to get to the end goal at the same place. It's what slope you're taking to get there and how quickly you're moving, like Les said, in and out of these different categories. So
Cool. Thank you, guys. Right, moving on to the next question, bringing JB firmly into the conversation here. So what options do we actually have to profile our athletes, JB?
So there's 2 different profiles we need to consider. One is for assessment. We will call it the force velocity profile. The other one is for training programming and load programming, and it's the load velocity profile. And if you do some mistakes in the load velocity profile, then you will not get to the target. So I'm going to start with this one. What you need is a speed device. You need to know the speed at which the maximum speed the athletes reach, because load is very easy to quantify, of course. And the other one is, so you can use radar systems, you can use timing gate systems. If you set some timing gates to have very short splits around maximum speed, so you can set some 2 or 5 meter timing gates around the 20, 25, 30 meter zone, or 40 if people are faster. And you can get the average speed because it's a plateau at that time. And you can get speed devices that range from pretty inexpensive app like MySprint to pretty expensive stuff. So that basically depends on your budget there. Then you can also assess the friction between the sled if you're using the sled and the track, because it will help you. That's very easy to do. You just need to buy a couple of dollars force sensor. You can find it online, or it's very accurate, and you just pull the sled at a constant speed and you watch the force that is needed, and you can calculate the friction. So that's for the load velocity. For the force velocity profiling, you just use the method that we've popularized, but that was existing. It's almost 1 century that the first observations of this exponential increase in speed were made by people in England and in the US. So you just need to know exactly position over time or velocity, running velocity or running speed over time. And so same story repeating. You can have very simple, basic, inexpensive systems to very expensive systems. The only thing you need to check beforehand is that they are accurate, because if you don't have accurate system, accurate timing, accurate starting, for example, if you have split times, but your trigger for the timing system is half a meter ahead of the sprinters, you will overestimate things. So inaccurate systems will give you inaccurate outputs, but you have at least today, I would say 5 or 6 different systems that have been validated. And maybe the most promising one is GPS systems or indoor systems like Kinexon and so on, but this is super elite right now. But GPS systems now tend to be more accessible, popular / accurate, at least for top speed. So that's the way to go. And so you need to follow the research and people using it and publishing it, because that's the information. People will tell you if it's accurate or not. And so, for example, to finish my point here, today I use confidently my sprint app, timing gates, if the timing gates start with the actual movement start, which is almost never the case, or radar, laser, 1080 Dynaspeed, motorized linear encoder systems, and GPS systems. I now provide, when I work with an athlete now, I just take my GPS systems if the weather is nice and the GPS, reception is accurate. Otherwise, I work with the radar.
Just on the friction assessment, just go a little bit. Just explain that a bit more if you want.
Sorry.
It's all right.
That's very super simple math. You just put a mass on the sled, and you know the mass of the sled. Let's say you have 40 kilos. Okay. You pull that sled at a constant slow speed, and you just watch the display of your weight system. I have one that's $20 online. It's very accurate, up to 300 kilos, more than I can pull. And the ratio between the mass that you put on the ground, that's the force that's normal to the ground, even in kilograms, and the force that you see horizontally is your friction coefficient. So if you put 40 and you read 20, you have a 0.5 friction coefficient with that sled on that track. And this is very, very useful, because then it helps you calculate the horizontal force outputs and better know, because everybody knows that the same 40 kilo of mass on a different sled and on a different surface will give you a very different, horizontal pulling force, and so a very different stimulus. So 40 kilo is not the same if it's a wet turf and if it's a super dry, track in Arizona. So, but it's 40 kilo anyways, but it's not going to be the same stimulus for the athlete. And this is part of programming. We have these questions at the gym for velocity-based train for the bars. We need to also have these questions on the field for sprinting.
So just to dive a little bit deeper, would you do that kind of assessment every single time? Like you said, weather changes, even if it's the same turf or track, different weather means different friction coefficient. Okay.
Maybe you need to have 2 extreme values, like a very high friction, very low friction. But if you work in conditions that are the same, you just do it once, and then it's roughly, typically on my track with my sled, my coefficient is 0.35, and I use that to better, calculate things. But you don't need it if you use always the same systems and the same conditions.
I'm going to get Les in here in a minute, but I just want to go into the GPS side of things, JB. People may have read research 5, 6, 7 years ago on GPS and maybe a little bit unsure of how it can be used in this kind of situation. What's changed over this time when it comes to GPS systems?
So first, I wrote one of these studies myself, and so that was 5 years ago, and technology is moving super fast. And even in the study we've published, we realized that on the day of testing, the measurements were done with the surrounding structures that were metal structures or stadium stands and so on, and the quality of the signal was not high. And we need to realize that these studies include different brands, different systems, different technologies. And it's not because it's GPS that it's accurate. Not all GPS are equal. And the most important thing is that if you have a GPS system, but you cannot have access to the 3 or 4 main accuracy metrics, first, this is not normal, because the manufacturer should give you access to that. And second, you should by definition doubt the quality if you don't have the metrics. So, and to me, these studies maybe had this issue. And for the last studies we did that we are going to publish very soon, we work with a very specific type of system. That's the GPXA ones. And the accuracy metrics are super high. And the comparison with the 1080, the radar, the timing gates are very, very high accuracy. In terms of inter-sprint reliability, it has the same reliability as the other systems. So that's where we are today.
Last question before I get Les in. What are those 4 data quality metrics that people should be like? If it doesn't have this, I'm asking questions.
Yeah. There's a great paper on that. You can add that to the notes. I will send it to you. But basically, first, that's the number of satellites, the raw number of satellites that are connected to your unit. If it's 10, it's different than if it's 4 or 5. You see what I mean? The second is a very technical term called HDOP. That is the horizontal dilution of precision, because the signal is basically coming from up down to your, between the shoulders unit. But what we are assessing is a horizontally oriented movement. So there's a loss of accuracy there. So these metrics allow you to know that. Then you can calculate what we call the signal to noise ratio. That's the very classical, what's the noise around my measurement and what's the signal I'm trying to find. And everything goes down to, for GPXA systems, the computation of the speed accuracy. And the speed accuracy is very important because it tells you how accurate is your measurement. Is it 1 meter per second accurate, or is it 0.1 meter second accurate? And this is totally different, because if you measure someone that is running at 10 meters per second, a 1 meter per second accuracy is a 10% error. And sometimes Les knows that and Ryan knows that. Between 2 athletes, if it's 9 or if it's 10, it's a different word. And so you need to know that. And unfortunately, when you try to have that from the manufacturer for the day you measure, you cannot have access to this information. And this is an issue, because by default, it might be super good, but it might also be super, super low. So, and this influences the results for sure.
Les, finally getting you in after peppering JB with some questions. How do you use GPS with your athletes?
Yeah, I've been taking notes over here. My notepad is filled.
Was that question for Les?
Sorry, it was. Yeah, it's for Les. Sorry, JB. Yes.
JB, I've just been taking notes on you. Well, so starting out, like just when I first started profiling, everything was my sprint. I was working out the back of my car, and I would literally do every single athlete, do the parallax and all that. Like it was a grind, but it was really accurate and it was really good. But then what happened is I needed to find a way to scale, because I needed more time, because I was having athletes come in every hour, didn't have as much time. So then what we looked at was doing GPS, and there's like a good, better, best situation on profiling. And really, really, really good is my sprint. But if you didn't have time, it was like, okay, well, GPS, like if we could figure out a way to have everybody just line up, run 30 or 40 meters and be able to get the profiles from there, then it would simplify things for me, because I'm not really great on the computer. I'm not really great at technology. Like I wanted to find simplest ways where athletes didn't understand that they were doing a test, but they were still getting test results and still getting profiling, bucketing from there. And then the best situation that I found after GPS was most consistent for me was 1080 or those types of devices or radar. But with GPS, it was like we're always on the go. We had this year we had 34 athletes across 3 facilities, and it was really, really, really hard to find ways to get consistent profiling. And for us, GPS was like an easy way to knock that out the box. And then from there, obviously, like you have your load and your volume and your intensity. You're actually tracking your sessions. So it was a good way for us to see like what is our plan volume versus what actually happened and intensities that happened with. And then we just recently got into acceleration speed profiling, which I'll let JB kind of go into the research on, but it was an easy way for us to look at our changes and what we had planned. So like everybody was planned on going towards velocity. Did our sessions actually reflect a higher velocity component within those sessions? And did we actually achieve the goal? So it was like it's been really cool to work with GPS. And the best part about GPS is that it's getting better. It's getting a lot better, actually. Just like over the past couple of months, just seeing where people are headed with it, it's going to be a really easy solution. A lot of companies are actually going to build a lot of this into their software. So making it simpler, obviously, is the goal, so that you don't have to be like a PhD to understand it, and you can still bucket athletes and still get the results, because that's really what we're looking for. Is we're looking to actually get the result and get the athlete running faster. And the less noise you have in that process, the better. And simpler is the best. So
currently, are you still having to do any work on the back end, or is the GPS system that you use do the work for you?
Yeah, well, not anymore.
Okay.
So honestly, what happened is my girl got pregnant, is having my daughter. I had no time, so started YouTubing like how to code and got a little bit on R, got a little bit just in the mix with that stuff, and then found some good people to help us build out a platform where we could just drop files in and it just runs the profiles for us. So we have it through GPS. We also have it through 1080, which is a great solution. And then I still do my sprint. Like I still use my sprint all the time, especially if somebody like sends me video and they have it set up right. But yeah.
Can also be delighted. Absolutely delighted here. Ryan, is GPS something that you use?
Yeah, we have access to GPS and things like that, and it's a very important piece to us. Going outside of sprint profiling, but just more into our overall like team load monitoring and things like that, because generally we have a very, very good, tight, precise idea about the load we're applying to athletes in the off season. We're just generally planned out. We know the intensities, we know the speeds and the volumes, things like that. As far as like testing and profiling, like I'm probably a little bit more old school. Like 1080 is like it's very good. Like I love it. I know the data is good, it's accurate, it's reliable. And then we go inside, outside. So depending on the weather of the session, like Virginia's weather is all up in the air, winter, things like that. Like we want our data and the data that we produce to be consistent across any season, whether it's indoor or outdoor. And currently we don't have the indoor capability to be able to get GPS inside. And so for us, it's not really good across the entire annual plan to be able to have some of our data come from GPS and some of our data come from 1080 or split times, things like that. So we know we can reproduce and recreate the data, whether we're inside or outside with 1080. So that's kind of where we go with it.
One thing I want to be sure people know here is when we say GPS, it doesn't have to be a 50 grand Stat Sports, Catapult, whatever system. These companies are doing consumer devices, but can these, and I'm guessing the answer, I don't know the answer is, but are these companies putting these kind of data processing within their systems so you can get the type of information that we're talking about here in the consumer devices? Les, JB?
I would say, like, without like bashing anybody, like I think all the consumer devices are close.
Okay.
What happens is that they actually capture the data at 10 hertz typically, and what happens is they have to downsize it to 1 hertz to transfer it to Bluetooth to the phone. So and that's not their fault, it's just a technology problem. But now with LTE, I think companies are going to be able to get that with the consumer devices to get like a high frequency to transfer across just directly to the cloud versus Bluetooth to the phone. And JB, you can correct me if I'm wrong, but we've done some tests on that, and we've been working towards it. I think it's close though. I think it's really close.
Yeah, I think it's close. My experience so far is that the funny thing is that I'm teaching a lot, and my students, bachelor, master's degree, they start buying their own GPS with this kind of, and we start cross comparing them. And what we did so far is that we observed that on some metrics like total distance, volume, maximum speed, so plateau speed, they are pretty close. But the problem is that on other metrics like maximum acceleration, when you need accuracy because speed is changing very fast, they're not. Well, for what I've seen. And the biggest issue is what Les said, is that they give you the end product is discrete data, discrete value, one speed, one number of sprints, etc. But you don't have access to the precision, accuracy data, and you don't have access to the raw data to do your own further processing. So I would say that the core technology might be somewhere about as accurate, but the end, let's say, user experience and access to data is definitely, less quality. But for most users, that's not the objective. And I would say that people really looking for elite performance and the last half seconds may want to rather use, more expensive systems. But it helps, popularizing the approach.
So you mentioned GPXE. Is there any other systems that you guys have used and had positive experiences with?
Yeah, we've worked with Stat Sports. The pro units are great. McLeod is really good. I would say like at the top, like Catapult, a lot of the ones at the top are really quality. Connexon, as JB mentioned, now has a GPS. And I believe they're working on some new stuff too as well. But I know Connexon was LPS, and over the past year have done GPS, and they've got a great system now. Who else, Ryan? Who else do we use?
Yeah, I mean we've used Catapult, we use Stat. I know McLeod's good. Like they've all been good and solid for us. Like currently we use Stat, and so yeah, like we've used the GPS and we use it quite frequently. We kind of run some of our profiling stuff in tandem, just kind of like line up and kind of assess and do that kind of stuff. But we always know that we can come back to kind of like our anchor measures that we do, like so for 1080. So for us, like I said, if we had access and we could, we had everything set up to where we could get really, really tight, accurate data inside all the time, like we would probably use GPS because it'd be so much easier. So it just like, again, it always comes back to logistics, environment, and like what you can do. And like, there's really not an excuse anymore to like not be able to collect data and get really accurate, tight data. It's just like, what do you find meaningful to you? Kind of what you have access to.
And just to add on it, like one of the things I get asked a lot is like, it's like, how often are we testing the profiles? And that's like one thing that like will kind of makes sense, like is what we're talking about and why we use 1080 to profile, because we only test really in the beginning, somewhere in the middle, and then just like we use GPS and we use all these other devices just to kind of check in, make sure we're on track. So we're trying to get as close as we can, but we don't, a test is a stressful environment. So we have to be very careful about when we introduce a test and how far away is it from the actual event. Like it's a lot different if you're working with a team than like right now, like what I do has a lot to do with off season, getting guys ready for a single event. So a test is a stressor. And I just want to make sure that like I'm gradually putting stressors in there and trying to collect data in the session without having them think they're being tested. And that's where GPS has been a really good tool. But like taking it with a grain of salt, like I want to have like a very consistent measure that I'm always going back to, which it's been 1080 for us. Like we could just set it up. We know it's going to be consistent along the way. And I think GPS is headed in that direction. So it's really cool. And then the other piece of it, which JB mentioned previously, is like once you have that test, the load velocity profile becomes, for me, really the most important, because that's the prescription, and that's how we're going to change that, so that when I have another test, I can almost predict what the outcome is going to be, similar to how I would in the weight room. I have a measure and I have a way to say, I'm going to make this change by introducing this amount of stress with this amount of intensity. And when it's all said and done, here's the outcome that I'm going to have. And we're almost predicting it with pretty easy success. Ryan's pretty humble, but I've seen him do it and he helped us get it going. So it's pretty cool.
Dive in, JB.
Yeah, I just want to add to the GPS question. Basically, to me, the top four, top five firms in the world might have about the same reception quality. The very big difference is going to be the data processing, the access to the accuracy metrics we've discussed before. Yes, no. If it's no, to me, it's an issue, and the overall dashboard and the access to the raw data. It's very important that anybody has access to the raw data, because otherwise you're influenced by the marketing / choice made by the manufacturer, and you cannot make your own choices in the data so you want to have access to the raw data. And here there might be some differences between the brands, and I hope they will update that in the future to let's say to give more access. I work now with Catapult, and we are going to publish a comparison study. The postdoc who is doing the analysis told me that years ago he was using Catapult already in an elite rugby club, and he told me at that time he had more extensive access to the raw data that with the newest system. So I understand there's some constraints, but that should be a basic.
Sticking with you, JB, and I'll dive into ask Les and Ryan to dive in if they've got anything to add here. But the acceleration profiling side of things, Les set you up nicely, saying that you dive into the research for us.
Yeah, so basically, as Les said, the test is a stress, and we realized working with European football soccer players that asking guys who sprint all day, all match long to do a 30-meter sprint is something. So we wanted to analyze the data, the game and training data a bit deeper. And so we've published, and there's some webinars on my website you can access. We've published a method where we collect all the acceleration and speed data. We plot them, so acceleration related to the running speed. We plot them together, and the maximum value of acceleration at any given speed down the spectrum, shows a linear tendency. And so this line, when extrapolated, is what we could call the game acceleration speed profile. And so we are right now working on comparing that to the classical linear sprint, because it's a win-win situation. If the information is different, then you have two specific ways to assess the players. If the information is interchangeable, if it's the same information, basically that's huge, because it means, as Les said, don't bother doing a linear test. Just collect 1 week of training or a game data. We figured out that 45 minutes of very intense soccer game was enough, and you'll know the FV or the acceleration speed profile of your player. So I'm very excited to push this result forward, and then to apply it to other sports than football, to US football, to rugby, and so on.
Perfect. Thanks, JB. Just a reminder to people, if you've got any questions, throw it in the chat, throw it in the Q&A. There's some French questions in there. I think that's probably best to leave to you, JB, if that's all right.
Yeah.
Unless Les and Ryan are holding something from us and the fluent French speakers. Getting Ryan back in here, just moving away from the on-field sprint profiling. Ryan, what non-field-based assessments do you use to aid your sprint speed programs?
Yeah, this is a pretty big question, I think, for sure. I think when we're looking at sprint profiling, like generally I like to look at the split times. Like I like to see what they do across an entire sprint. So we're able to zone in on a specific area and segment relative to the position group, where they're weak or where they're strong. Now, where the force velocity profiling comes in is very, very important in like showing their strategy. So it's not what you did, it's how you got there. And so from that point, you can see, is it a mechanical effectiveness issue, or is it a force producing issue, or things like that. And then from there, we've got very specific profiling strategies on the periphery, where it's almost like it's using almost akin to like a Bondarchuk type system. So like people have conflated load velocity profiling and force velocity profiling for many years. But how we look at load velocity profiling is a specific strength profile for our athletes. So we know that if they have a force deficiency, we're going to look at the heavier loads relative to the percentage of body weight. So it's like, can you move heavy loads fast? Because if you can, then it's largely going to be a technical issue surrounding your ability to accelerate, because you have the specific strength qualities to be able to accelerate fast. And we've seen that across some athletes. They have a low F0, a low A max, yet they can move heavy loads faster relative to their position group. Well, it's like they have the specific strength qualities. And so there's this idea floating that like heavy sleds or loaded sled work is all that's needed to like apply the stimulus to the problem and attack it, which is not the genesis of force velocity profiling at all. It's really only one piece. And so like if we know that we have an athlete on the opposite end of the spectrum that has a low V0, they can accelerate well, but they just don't have a good top speed, we're going to look at the lows relative to a smaller percentage of body weight. So it's like, can you move really low loads fast relative to your position of body weight? So you're getting a specific strength profile and you can compare it relative to the average of the group. Like what's the slope of that profile? And then from there, you can dive into specific developmental exercises. So there's this bridge between what you do in the weight room in a general sense and what you do sprinting on the field. And if you can develop a few exercises in the weight room using technology and wearables, such as like wall drives with gym wear attached to you to get velocity, or using output to get triangular velocities in certain drills, like you can you have the ability to overload those drills and have like a specific developmental exercise battery developed around acceleration or maximal velocity. And then obviously like the more specific drills as well. So it's like, okay, if they have an acceleration issue, it's going to be your more concentric, powerful base exercises. We'll use like split stance broad jumps. We'll use triple jumps, triple broad jumps. Like those exercises, like their ability to perform those well is going to be indicative of their ability to be able to project and orient their body forward in space. And so on the opposite end of the spectrum is, can you get measures around straight leg bounding for speed through timing gates or specific speed bounding drills? Like these are special exercises that their ability to do these well is going to have high degrees of transfer to the competition exercise. And then as we move further away, you have things that we like to call specific joint profiling. And I took this a lot from like Alex Matera and James Wild and their research and their work. But what is some of the specific joints that lead to high degrees of success of sprint performance? So your ability to have large peak forces of hip extension and do it quickly is going to be a big marker of sprint success. And so we do what's called a supine single leg hip extension test. And like their work has been key and pivotal in that area. And so your ability to basically recreate the position of the knee, because the position of the knee is going to cause large variances in the data. But it's basically an isometric test where they're pushing into an immovable object, a pad, a barbell, things like that. And you can set the degree of the angle of the leg to be rather straight to mimic more of like a straight leg max velocity position, or bent at about 90 degrees, so more of an acceleration based position. And so you can get peak force and then forces at 100 and 200 milliseconds. So you can get like a broad spectrum of what the hip's capability is to do in an isolated environment. And then around the foot and the ankle is the other big area and big key. So your RSI values. So you want to look at RSI, you want to look at double leg and single leg, but then look at strategy of contact time and air time. So around those specific joint profiles, you can see weaknesses and areas of low-hanging fruit that you can kind of attack with some of these athletes. And then finally, just to kind of wrap it up so these guys can jump in, but you got your general preparatory exercises. So at best, they have diminishing returns, right? So it's like, we want to see if there's a red flag around your ability to move maximal loads, your ballistics, your Olympic lifts and things like that. They're on the periphery that we want to monitor to see if there's like big key areas that have gone underdeveloped. But largely, we're looking at the more like specialized transfer of exercises to be able to impact the performance.
Cool. Love it, mate. Thank you very much. Anything to add there, Les, JB? Any non-field-based assessments that you use with the athletes, Les?
I mean, like, he just gave a dissertation.
He did. He did. Sorry to follow that.
No, I'll hop in. Well, first, I literally I forgot a company. I feel bad. Titan is a really good GPS provider. I meant to mention that in the past part, but I've been looking into what they're doing. It's pretty cool. But yeah, I mean, basically, like the way that we're looking at it, like we have 6 to 8 weeks typically, whereas like I know in team sports you have bigger windows. So what we're looking for is the highest degree of transfer. So like when we first started training and I started reading JB's research, I misinterpreted the research to think just do heavy sleds the whole time. And like what I was doing is I was literally doing heavy sleds, and like I was watching, I was tracking the 5 and 10 yard splits, and they were incredibly, like they were getting so much faster. They're improving a ton. The projection was great. Then they would get to the next segment, 10 to 20, and they would look terrible. Like they were running in mud. They weren't able to get a fast enough contact time as their velocities were increasing. And what was happening is I was actually making the later segments slower. So like we talk about all the time, like surfing the curve. So being able to attack the whole curve and when and where and understanding what exercise is going to get that adaptation that we need. And then how long do we need to apply that stimulus in that zone? So when I have 8 weeks with a guy, there's, you know, guy A, he come in, like I had guys coming in running 4.5, like 4.8, 4.9, and they were trying to run 4.5s. And then I also have linemen that are coming in running 5.5, trying to run 4.9. So what we're looking at is like, how do we apply a stimulus in that bucket? And what are those exercises? What's the selection of drills that we're going to apply in that bucket? So for early acceleration, we picked like our 4 or 5 drills that we knew had a high transfer. And our goals were getting hip projection. Our goals were being able to project the shoulders, being able to attack back and get a retraction step. So all of our drills looked like that, but they were also on the physical side applying a more of a force stimulus. And then as we progressed, we looked at different segments of the run, like the 10 to 20 split, the 20 to 30 split. Our exercises started to look like straight leg bounding, or maybe it was like a triple jump, like, or there was like different exercises that we knew would get a high degree of transfer, which also went along with lighter loads, medium loads that we had a target velocity for. And then the goal was to get everybody to the point where the session looked like warm up and sprint. Like that's the end. For me, like the last 3 sessions of the year when we're prepping is like a self-guided warm up and 3 or 4 sprints that are pretty fast. That's my goal, but it doesn't look like that the whole way. Like we're trying to chip away to get different adaptations at different portions in the run. So like Ryan said, I don't want to overstate it, but output was a really easy way for us to track like RSI throughout the sessions and seeing it, like, are they becoming more reactive? And if they're not becoming more reactive, we had to find a drill set that would get them more reactive. Also looking at thigh angular velocity. So number 1, can they get the thigh range? This is Ken Clark's research mostly. So I don't want to mess it up, Ken, if you're listening. But number 1, can they get the range that we're looking for? So if an athlete, like our linemen, a lot of them would have like 86 degrees of range. And we know that the elite sprinters have 100 to 102 degrees of range. So obviously these guys are 320 pounds. So we need to move them in the right direction. You can't go broke making a profit. So getting 4 more degrees of separation between their thighs when they run, okay, that's gonna produce a better stride length, but also more potential to create a whip from that action. So it's not just how wide, how big can the thigh angle get, it's how fast can you accelerate that thigh to close. So it's creating that switch pattern, and which was a variable that we started tracking a ton. And then from there, it was like, how much of that is front side versus backside? So originally growing up, we're like, oh, you need 90 degrees in the front, no backside, but that's unrealistic. Like the best sprinters in the world have like 75 degrees front side and 25 to 27 backside. Backside becomes really important for projection. So looking at variables like that, we're able to really look at the physical and technical adaptations we needed to make, and then found drills that would actually get that adaptation without us going in there and over coaching or manipulating or telling them, hey, put your foot here or do this here. Like that's how I was coaching when I first started, because that's what I thought would sell, and it did, but it was a pretty poor job. Like I didn't create fast people. And what I'm realizing now is like, how can I get an adaptation without talking? It's hard. It's really hard, but I need to put you in environments where I'm going to get that result. And that's where the profiling, JB's research, and Ryan's taking it to a whole new level, teaching me how to how to put the physical and technical together, but not talking. So that's been the overall goal. It's like if I can finish the session and I didn't say anything and I got the result, that's perfect. So
honest of you, Les. JB's been patiently waiting. Off you go, JB.
Yeah. I just wanted to have everybody notice that what Ryan and Les just did shows that research is isolating things to study one thing at a time better. And coaching is integrating things. So coaching has to integrate different research, different types of knowledge to coach people. And so for research shouldn't say you should do this or you should do that. Research should just say, we tested this, this is how it works, this is the effects. Now it's in your toolbox and you have to manage that. And this is very important.
Absolutely. Thanks, JB. Come back to you, JB. We've got a few more minutes. Any more questions? Dive and put them in the Q&A and the chat. Common misconceptions of force velocity profiling. The reason this came up was when I was prepping for this, and you put force velocity profiling. There's particular coaches that come up that talk about the negative, I suppose, the negative side of force velocity profiling and getting a little bit angry about it with lots of comments underneath. So over to you, JB.
Yeah, so it's like anything else. You can find negative comments on everything. So it's so first, one comment is that it's not useful. I guess the 45 minutes we've just discussed tends to show that it might be useful at some point, if you don't expect something that it doesn't provide. The second thing is that it's not scientifically valid and so on. The thing is that if everybody in the world had 50-meter force plate systems, everybody would measure force and velocity of running people. There would be no debate. Okay, so and maybe the people who are bashing the concept today will publish with it in a few years. So that's just a social media circus part of things. The final thing, and I think this is on us, is that yes, maybe we are using some terms that are not purely and biomechanically perfect, like the term power. The term force is ground reaction force is ground reaction force, but the term power is yes, misconcepted in our approach. We are referring to the changes in kinetic energy of the center of mass of the runner related to the horizontal component of their push onto the ground. Okay, this is so we should refer to only the part of power output that comes from the muscles to the ground and that moves the center of mass forward. But we can, and this would be more correct, but we can spend hours talking about terminology or spend hours helping people improve speed of their athletes. And that's the part I've chosen. But now we are very careful because my job is to be a professor at the university. And we are very careful in clearly saying this is only one part of the human muscle power output, the part that is, driving your body forward. And I think this is a very important part. I did a funny video a couple of months ago to answer some critics like this. I was pushing the ground super hard and producing muscle power a lot. And I was not moving because I was pushing on place. And I said, here, I'm not producing any type of force, hence change of energy or power in the speed, the running direction. So most of the misconceptions come from people over-interpreting because not reading, I think, deeply enough our texts, or our own words not being accurate enough. But if we are super accurate at some point, we need to simplify down things. And I accept the fact that when you simplify, some people might interpret that as a mistake, yes.
Over to you, Les.
Yeah, I'm not as nice as JB. When I see comments, I look and see who have you coached. So, like right now, to me, simply put, like in a nicer way, like what I found is like I need to find ways to justify the changes that I'm making. And if there's research and I can point to that research and say, here's the adaptation that researchers show me, it makes it really simple to follow along, then that's probably what I'm going to do. I think a lot of criticism comes from people that aren't ever stress tested in a coaching situation where they have clients' money on the line and they got to figure it out, or that's the end of their career and their family doesn't eat. So that's the way I look at it. But yeah, next question.
Good work. Right. 10 minutes to go. We'll dive into these questions. First one, I don't know if either of you guys know this. Is it possible to calculate a friction coefficient with exergeny? Or is it only possible to work and decrease the unresisted running speed?
I want to know the answer to this too.
Yeah. Yeah, my experience is that by definition, there's no friction on the ground with exergeny. The friction is only in the system itself. So I would tend to do exactly the same. Use that load device. You use that to weigh suitcases or meat and it's $20, and you can pull the exergeny at a constant speed, and you will read the amount of force. So you don't assess the friction, but you assess the pulling force that the speed on the exergeny gives you. It has different speeds, and so you can test the reliability of that and so on. But it's not meant to be a device that provides accurate measurements of friction. It's a device that gives you levels of friction, categories of friction.
While we're on the exergeny, recommendations for load velocity profiling with exergeny due to availability and convenience, if it's worth it. Thought about utilizing crane scale for accuracy.
Yeah, crane scale. That's the word I was looking for from the beginning.
Okay.
Yeah, so maybe Les or Ryan, have you used the exergeny so far? Because I don't want to.
Yeah, I actually used exergeny a lot, especially on the road with my bobsledders. We just had the Olympics this year, so bobsledders would use exergeny. I haven't done any load velocity profiling on it, and to be honest, like we did so much resisted running during the off season and during the season that my bobsledders pretty much knew like what was a heavy load and what was around correct. Like, I mean, the session would just say, I would write down, just do a heavy load, like 5 meters or 10 meters, or whatever it was. But I haven't done a load velocity profile, but I'm going to, now that I know how to do it with the exergeny, probably will. So I'll test that out.
Ryan, were you going to dive in there? No problem if not.
No, I was just going to say that. No, we haven't used the exergeny. I would just be sure that like the load is like very, very super precise around like the load velocity pro, and just because like I haven't used an exergeny personally, but if there's like any like fluctuations in the amount of resistance that's in it, it's gonna affect the load velocity profile. So like that's why for us, like we're very specific about, we always use sleds or 1080. And so like the surface that we run on is indoors, and it's exactly the same every single time. So like at least gives us peace of mind that we know that the loads are exactly the same.
Yeah, I would just want to add that to avoid another misconception, when we talk about load velocity, we mean load / maximum velocity you can reach with that load, to be clear. So if you want to do a load velocity with the exergeny, you need to have let's say a speed, load option on the exergeny / maximum velocity.
Cool, thanks, JB. I'm going to come to Ryan for this next one. So from Pete, when you work with linemen, do you prioritize heavier sleds more in the prep, as the 0 to 5, 0 to 10 splits are more important for their sport demands, at least compared to skill position players?
Yeah, absolutely. I think when you talk about profiling, like there's this conception of like, just because the data tells you to do something doesn't mean you have to do it, right? Like you're the coach. It's the whole idea of like balancing like artist and engineer. Like, there's a specific general demand that athletes have, or their strengths and weaknesses. If you're looking at their tau value, their acceleration or force dominant, but you always want to train to the position requirements. So it's like, if I know that linemen play in a small box and have this positional demands around them that are based largely in acceleration, that's going to be the majority of the stimulus I'm going to give them, because what makes them great at their position inside of their sport is their ability to apply large forces, accelerate in small spaces and things like that. So I'm going to train to to specific profiles, but I'm also going to keep taking into account position specific demands as well.
Les, anything to add?
Yeah, this is my first year working with this many linemen, but I had 20 of them, average weight 315 pounds. And what I realized, like, yeah, like we did do a lot of heavy stuff. We started off pushing, then we went to shoulder resisted and then waist resisted runs. But there is a velocity component to them. But what we noticed is that the velocity component for them is they're reaching 95% of their velocity in 15 yards. So we're touching on both sides of that curve where we're working that, the more loaded force side, but we're also doing a considerable amount of velocity. And when you watch these guys play, we have two guys that are going to go pretty high, and I was watching their film. I mean, these guys are running downfield, and they're running 15, 20 yards downfield and blocking, and they're fast, and the requirement for them is speed. And even the guys that are playing on D-line and the edge especially have to be fast. So we typically start them heavy and loaded in force base, but we're also working the velocity side, and we're trying to improve their contact times, because even in their positional requirements, they have to have decent contact times, and we want to be able to touch on that. I saw a question about transition, so I'll get to that on the next question, but we definitely do focus on velocity for those big guys, and more so than I originally planned to be honest.
Rather than me reading that out, did it go to everyone? Oh no, it didn't. I'll read. Shall I read it out, Les, and you can attack that question that came into us?
Oh, for sure.
So after profiling my athletes, I've noticed that a few that are deficient in their transition phase after the drive phase. Originally, I've been attacking the issue 2 to 3 times a week, right from the start, by using variable load approximately 5 to 15 kilos on 1080, where 15 kilos would hit around 10 to 15 meters, where that transition phase is. Would you attack this issue right from the start, or would you surf the slope, hoping that it clears up over time? Also, is there a better way to attack transition phase other than what I'm doing now?
Yeah, and I'm going to give an ambiguous answer, unfortunately, because it's something I'm still trying to figure out. Because what I realized is, like, the beginning part of the training, everyone's doing force-based, higher loads, more power-based stuff, which you see immediate returns from, and it's easy. The transition is difficult. So finding like what stimulus to apply in that transition is really hard. So what we found, like, transition loads were really good with 25% VDEC was really good for the second 5 of the 10. So you break the 10 into 2 5s, the second 5, so it's like from the 5 to the 15 was really good. The 10% VDEC was really good from like 15 yards to like 30 yards. And then past there, it was really velocity. We were seeing the biggest changes. So our goal is to try to get to velocity, through, like, you have to go through the ranks of force-based and power-based and gradually get to speed strength. But we want to get guys there within the right amount of time to start to get those adaptations. So we realized, like, what helped the transition the most was getting to the opposite end of the spectrum, which was velocity, the faster ground contact times. But we knew we couldn't get right there. So it's really just a means to an end. Like, for us, it was about going through the 25 VDEC and 10% VDEC to get to velocity safely and get to velocity where it was effective, where they're powerful and they can handle that amount of velocity, rather than saying, like, I'm going to get a massive adaptation from that, if that makes sense. So, like, we got the biggest adaptations in our transition when we finally got to that velocity phase. Then we started to see that second 10 improve. So, like, one of the biggest KPIs we had for our big linemen was the second 10 split time. So guys were coming in like 125, 126, and they were leaving out, I mean, no lie, like 114, 115. But that didn't happen until the last block of training. Guys were still in the 1-2s until the last block of training. And then we finally turned that velocity switch on, and we started to see the adaptations from there. That's when the transition was improved. So in the middle, it's also good to understand that we're applying stress, and that stress won't show up in that phase. Like, that adaptation won't show up right there in that phase. Like, you're not going to apply stress on Monday and then next week come back and look at it and be like, oh my God, they're way improved. Sometimes it takes 3 to 4 weeks. And what we realized, even from the heavy sleds, it took us 4 weeks to come back from those heavy sleds to see massive adaptations, and even in that phase. So it's just a delayed training effect. And I know Ryan is probably really good at talking about this, but just looking at the phase and potentiating the next phase. And that's where we started to see everything come together. So just looking at the whole picture from the top down, we can't expect it until the end if we're going on this path.
Dive in, Ryan. Did I come to JB to see us out?
Yeah, I mean, I think the accommodating resistance stuff and things like that obviously like have been huge for us on multiple different levels, and how we train our guys. But just like going back to touch on the lineman stuff real quick, like one of the biggest advantages of JB's work and the spreadsheets that he has is like his ability to essentially model velocity over time. So it's like one of those untapped areas that people just look at these 5 variables and they stop there. Well, it's almost like if you look at the slope, and like linemen can accelerate well, but they have low top end speed, just raising up their top end speed ability will lift their acceleration profile up with it. So that's been a huge area of like being able to train these guys, and what Les kind of alluded to is like tapping into that neurological effect. And so like these guys need to be athletic guys, but there's always going to be a balance and a trade-off to the two. I think lastly, like we need to be careful about only applying physical stimuluses to technical issues. Because like a lot of these guys don't know, like just don't understand like the smoothness of being able to like climb and rise their hips, and like the rhythm and the cadence to being able to run these times. And so like there is only looking like physical interventions, I think, can lead people down a path of being able to stall a little bit. And I think there is like, yes, like there's always physical issues. Like that's why we have these like profiles and these exercises centered around these like different issues to be able to address these physical issues that they have. But sometimes it's just teaching these guys how to be able to like transition and climb a little bit too, and being more like reactive around the ankle. Like reactivity around the ankle is like big low hanging fruit for a lot of these athletes. Their ability to like handle and tolerate loads in these forces. Like their body, this whole self-organization argument is saying like, if I have a weak link in my foot and my ankle, I'm not going to be able to apply the technical intervention that you're wanting me to get. So like being able to attack these certain areas and isolate them and know how to test them is going to be huge.
Love it, you guys. JB, last but not least.
No, I had something in mind, but it escaped. Yes, delayed effect. It's the most understudied thing in sports sciences. 99% of the studies give you a pre-post analysis, and our own studies as well at the beginning. Pre is only one measurement, so you don't know the baseline, and we should do 2 or 3 measurements to know the baseline from which the training effect will be measured, quantified. So we know the variability, and is it really off the variability? And the second thing is that we measure things immediately post. And this is a mistake. And we've shown that in a very specific study. And now we do differently. Either we set a taper period before doing the post measurements, or we do repeated post measurement. And in terms of heavy resistances, I would even say that the first post measurement is almost useless. You need to wait at least 1 or 2 weeks, or you need to, because there's also early peakers and late peakers in terms of adaptation, which is a mess, but we want to individualize the effects. And if you have a pro day or an NFL sprint on D-Day, you want to be the best here, not 1 week later, not 2 weeks later. And delayed effect is almost never studied. And this should be studied better, yes.